911, what's your emergency?
I need an ambulance. My friend, she fell biking. I think her leg is hurt really bad. Please, please, hurry.
What do we have?
24-year-old female. Imaging confirms multiple breaks along the femur shaft.
Okay, let's prepare for a full open repair with a 10-inch incision.
Wait! We can use this new device, the Samurai. It only requires a 5 centimeter incision.
Hello everyone, we are Senior Design Team 4 from the Biomedical Engineering Department. Over the past 2 semesters, we have been tasked with creating a minimally invasive cable passer for trauma surgery. Currently, traumatic long bone injuries require fixation through very large incisions. These incisions drastically increase the risk of infections as well as lengthening recovery time. Additionally, large incisions make patients much more prone to nerve damage and muscle atrophy. Currently, wires and cables for fixation of the bone are used. So the goal of this project was to develop a device that would allow for that passing of a wire around the bone for the fixation through a very small incision. Additionally, we focused on minimizing tissue entrapment.
The team was able to design a 3D metal printed device called the Samurai that is composed of a 2-piece, each piece being blunt tips and having enough tactile feedback to allow the surgeon to travel and navigate through soft tissue, avoiding any important structures from being trapped between the bone and the device. As seen in the video, that uniaxial action of the device can allow for the separation of 2 pieces, with the first piece being entered by being hooked under the bone and the second piece sliding through the first piece and joining in the middle, limiting it, letting the user know that the device has been properly used. From there, a wire can be pushed through the clean path allowed by the open medial ends of the device, with a simple removal of the second piece and the first piece being able to be anchored outward and pushed out, minimizing the amount of tissue damage done by the device as well, leaving the wire free and exposed.
After completing your first surgery using the Samurai device, what's your feedback for the engineering team?
While using the device, I was able to have tactile feedback the whole time, both while inserting each piece and when the tips met on the medial side of the bone. The feedback allowed me to be confident there was little to no tissue entrapped between the bone and the device.
This device also allowed for the surgery to be much quicker than previous surgeries, which limits complications from anesthesia and other surgery factors.
Along with the faster surgery, we were able to use a smaller incision size, which will allow the patient's recovery to be a little easier compared to a fully open repair.
In the end, I could see this device being able to pass wires both in trauma surgeries and in orthopedic hip replacements and other long bone repair surgeries.
We wouldn't have been able to do this project without the help of Resolve Surgical Technologies. We would like to specially thank Tim, Emily, Matt, and Joseph, as well as thanking our primary advisor, Dr. Hahn, and our secondary advisor, Dr. Lee, along with all other staff and faculty of the Biomedical Engineering Department and other departments as well.
We'd also specifically like to thank Russell Stein from the Materials Department, who supported the team in anything that had to do with 3D metal printing. He was a really great support to us, and we really appreciate it.
Thanks for watching our video. Hope you enjoyed.